Solving equations with radicals, Part 1. In this video, we'll identify that some radical equations have no solutions, and we'll solve some equations, and then we'll check the solutions in the original equation because sometimes we get solutions that aren't valid. This is a radical equation because the variable x is inside a square root sign. Root and radical are different names for the same thing. So if I want to solve an equation, in general, I undo what is done to the variable by doing the opposite operation. And the opposite of square root is square. So I'm going to square both sides, and the square and the square root cancel out. And so x is equal to 16 squared, 256. Now if I check that back, the square root of 256 is 16. But what about this same situation but negative 16? You know, the square root sign indicates the principal or positive root. And so anything in a square root can't be equal to a negative. If you see a square root equal to a negative, you can know right away there is no solution because the square root is positive. Here's another radical equation. Negative 1 plus the square root of y plus 12 equals 4. If your square root is not alone on one side, it's more difficult to get rid of the square root. So let's start by adding 1 to each side. That will give me the square root of y plus 12 is equal to 5. Now I can square both sides to get rid of the square root, and so I get that y plus 12 equals 5 squared, or 25. And I just need to subtract 12 from each side to find out that y equals 13. If I try that 13 back in the original equation, I have negative 1 plus the square root of 13 plus 12 equals 4. That's negative 1 plus the square root of 25 equals 4, or negative 1 plus 5 equals 4, which is true. So the solution is y equals 13. Here's an example with square roots on both sides of the equal sign. The square root of 5x plus 14 is equal to the square root of 3x plus 10. I want to get rid of square roots, so I'm going to square both sides. And after I square, the square root comes off, and all I have left is the expression inside. So 5x plus 14 is equal to 3x plus 10. Now I can solve by subtracting 3x from each side. That will give me 2x plus 14 equal 10. Subtract 14 from each side, and 2x is equal to negative 4. Divide by 2, and x equals negative 2. Can x be a negative number inside the square root? Well, it can if it makes the expression inside positive. So let's check. The square root of 5 times whatever x is plus 14 should be equal to the square root of 3 times whatever x is plus 10, and we know x is negative 2. So if I multiply 5 times negative 2, that's negative 10 plus 14. And if I multiply 3 by negative 2, that's negative 6 plus 10. So that gives me the square root of 4 is equal to the square root of 4, which is certainly true. And it's okay if the answer is negative as long as the expression in its entirety inside the square root is positive. So x equals negative 2 is a good solution. X is equal to the square root of x squared plus 3x plus 9. Let's square both sides to get rid of that square root. So x squared is equal to the expression inside the square root. The square root's gone. X squared plus 3x plus 9. If I subtract x squared from each side, I get a nice little equation. 0 equals 3x plus 9. And so I can subtract 9 and get 3x equals negative 9, and divide by 3 and find out that x equals negative 3. But if I check that back in the original equation, I have x, which is negative 3, equal to a square root. And I cannot have a square root equal to a negative number. So even though I found a solution, x equals negative 3, there is really no solution because the square root cannot be equal to a negative number.